Can you see my screen?
Yes, ma'am.
Today we have to discuss the reactions with oxygen. Okay. So group 2 metals. Group 2 metals, I think you know what are group 2 metals. Can you tell me the names?
Alkali earth metals.
Yes. Now tell me the names of the elements.
Beryllium, magnesium, calcium, strontium, barium, and radium.
Yes. So all these group 2 metals, they burn in air. Burn in air means in air your oxygen is present. So they burn in air and burn more rapidly in the oxygen gas. So the metals, they form white colored solid oxide. So you can see this reaction. This is your alkaline earth metal, magnesium. It burns with oxygen to form magnesium oxide. Okay, it is what? It is a solid. So remember its state. Magnesium is a white solid oxide. Magnesium oxide is white solid oxide. And what is the acidic or basic nature of it? Then we know that metallic oxides are always basic. Metallic oxides are always basic. So magnesium oxide is also basic in character. So this experiment we can do it in the lab also. That magnesium ribbon, when we burn it in the presence of oxygen, it burns with a bright white flame once it is ignited in a Bunsen flame. You have heard of the term dazzling white flame, right?
Yes,
So
ma'am.
yes, so it burns with a dazzling white flame. Now the group 2 metals, they get more reactive with oxygen going down the, if we talk about, as you say, that beryllium, magnesium, calcium, strontium. So as you go down the group, so the reactivity with oxygen, it increases. Okay, like calcium reacts with oxygen more rapidly as compared to magnesium. Similarly, strontium reacts with oxygen more rapidly as compared to calcium. So the reactivity increases as we move down the. Why? The larger atoms lose their outer two electrons more readily. Why the larger atoms lose? Because they are far away from the nucleus attraction. They are far away from the nuclear attraction. The larger atoms, they lose their outer electrons more easily than the smaller atoms in the group. That's why the reactivity increases down there. Got it?
Yes, ma'am.
Write it down.
Yes, ma'am.
Yes. So if we talk about barium metal, then barium metal is so highly reactive that it must be stored under the oil to keep it out of contact with air. Okay. So barium metal, as we know that reactivity with oxygen increases. We have beryllium, then magnesium, then calcium, then strontium, then barium, then radium. So as we know that reactivity with oxygen increases as we move down the group, but barium is so highly reactive that it must be stored under oil to keep it out of contact with air. That's why it's stored in the oil. So it is an important point. Write it down.
Yes, ma'am.
Okay, now this is the action of water to your alkaline earth metals. That these metals, they react slowly with water, liberating hydrogen and forms metal hydroxides. For example, calcium. It reacts with water slowly. It forms calcium hydroxide. Okay, in the its solution is also known as lake saline. In water, it is known as lake line. Thus, hydrogen gases evolved. The reaction with water becomes increasingly vigorous on moving down the group. Similarly, as the oxygen reactivity increases down the group, similarly, the reaction with water also increases down. So, beryllium, if we write down the trend, it is calcium, strontium, barium, radium. Okay, now here what happens, that beryllium, it does not react with water. Okay, but magnesium, it reacts only with hot water. That means the reactivity increases vigorously. That means beryllium, it does not react. Magnesium react only with hot water. Okay, while other metals, they can react with cold water. So calcium can react with cold water, but not as energetically as the alkali metals. So the reactivity is less as compared to the alkali metals. Okay,
Yes,
write it
ma'am.
down. Can you hear me?
Yes, ma'am.
Sorry, that was a network problem. I got. Can you see my screen?
Yes, ma'am.
Write it down.
Yes, ma'am.
So now next thing is very important. Its reaction. We'll see its reaction with the reaction of group 2 oxides and the water. Okay, now we are seeing the reaction of their metals with oxygen, metal with water, right? But now we will see the reaction of group 2 oxides with water. Okay, so magnesium oxide, which is only slightly soluble in water. Okay, it forms a weakly alkaline solution of magnesium hydroxide, MgOH2. A saturated solution. What is the meaning of saturated solution?
The solute is completely dissolved.
Saturated solution means that you cannot dissolve more solvent. Okay, it is completely saturated. It is enough. It cannot dissolve more of the solute. Okay, that becomes your saturated solution. Of magnesium hydroxide, it will have a pH of about 10. Why it have a pH of about 10? pH of about 10 means acidic or alkaline?
Alkaline.
Yes, it is alkaline. Why it is alkaline? Because when magnesium hydroxide it dissociates, it will give you magnesium 2 plus ions plus hydroxyl ions, and these for the about these OH minus, they are responsible for the alkalinity. Okay, now remember the pH, it is 10. Calcium oxide reacts with water to form calcium hydroxide. So the reaction is same. Calcium oxide, it reacts with water to form calcium hydroxide. When water is dripped onto the surface of a lump of calcium oxide, it causes a vigorous reaction. Okay, the reaction is vigorous here. It releases so much energy that some of the water boils off as the solid lump appears to expand and cracks open. It will break. Okay, it will have a crack. The reaction releases so much amount of energy. In excess water, some of the slightly soluble calcium hydroxide dissolves to form a weakly alkaline solution. Now here it is a weakly alkaline solution. Calcium hydroxide, when it dissociates in the aqueous solution, we have calcium 2 plus ions plus 2 hydroxide ions, right? So the higher the concentration of aqueous hydroxide ions in a saturated solution of calcium hydroxide, it results in a pH of about 11. So due to this, the pH is 11. Okay, so what you have to note in this slide is that if we talk about magnesium oxide,
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
it is slightly soluble in water and it forms a solution of magnesium hydroxide. If you see saturated solution means you cannot add more of the solute to it. So if you see the pH of its saturated solution, it is about 10. But if we talk about calcium oxide, it also reacts with water. The same product we have calcium hydroxide. Okay, now this reaction, it releases so much amount of energy that the solid lump appears to expand and it cracks open. Okay, in excess water, some of the slightly soluble calcium hydroxide dissolves. This is also slightly soluble. This is magnesium hydroxide is also slightly soluble. So it also forms a weakly alkaline solution, but it have a pH which is slightly higher than magnesium hydroxide. Okay. So why this is so? Because of the higher concentration of aqueous hydroxide ions in a saturated solution of calcium hydroxide, its pH is about 11. Okay.
Yes, ma'am.
Write it down.
Yes, ma'am.
Okay. Next is the reactions of hydroxide with dilute acid we'll study. So the alkaline hydroxides of group 2 metals, they will all be neutralized by the dilute acid. The neutralization means when acid plus base reacts, it forms your salt and water. So the neutralization reaction takes place here. You have a hydroxide of metal plus a dilute acid in which concentration of water is higher. So you have a salt and water. Okay, that are also your neutralization steps. So, for an example, if we see magnesium hydroxide powder, we have magnesium hydroxide. Since it is powder, it is in the solid form. We react it with a dilute HCl. We have a salt of magnesium chloride plus H2O gets liberated. Similarly, if we do this in case of HCl, like H2SO4 sulfuric acid, we have magnesium sulfate. Okay, because this is a double displacement reaction which is taking place. The cation of this is attaching to anion of this, okay, plus water. Similarly, if we see barium hydroxide solution, so this reaction, you should know the products of the reaction. With HCl, you get the chloride, and with H2SO4, you get the corresponding sulfate. Barium sulfate is important because it forms a white colored precipitate, okay. So it settles down, it separates out of the solution. But barium chloride, it is soluble. So we represent precipitate by a downward arrow also. Downward arrow means that it is a precipitate. Okay. So barium sulfate is a white colored precipitate which settles out of the solution. Clear?
Yes, ma'am.
Write it down.
Yes, ma'am.
So this is your homework question for today, that you have to write down the balanced chemical equations including state symbols for the reaction of strontium with oxygen and strontium oxide with water.
Okay, ma'am. Yes, ma'am.
Okay, now next is your reactions of group 2 carbonates. So the group 2 carbonates, they have the general formula XCO3, where X is your alkaline earth metal. So the carbonates of magnesium, calcium, strontium, barium, they are all insoluble in water. Carbonates are insoluble. Okay. However, the carbonates of all carbonates, they react in dilute acid like H2SO4. So it forms a salt, water, and carbon dioxide. So remember that here we have three products: salt, water, and carbon dioxide when we treat your metal carbonate with acid, dilute acid. Now here the magnesium sulfate which is formed, it is soluble in water. This remains in aqueous solution and no solid carbonate will remain in excess dilute sulfuric acid. But if we talk about sulfates of other group 2 elements, they are much less soluble than magnesium sulfates. That means the solubility of group 2 sulfates decreases down the road. Got it?
Yes, ma'am.
Write it down.
Yes, ma'am.
Now next is the thermal decomposition of group 2 carbonates and nitrates. So this is the last topic. In thermal decomposition, what we do, thermal means we decompose it in the presence of heat. Okay, so carbonates and nitrates of group 2 elements, they decompose when heated. And what are the products? You have to remember the products. If we talk about carbonates, it breaks down to form metal oxide and carbon dioxide as a gas. The temperature at which the thermal decomposition of group 2 carbonate takes place, it increases going down the group. Okay, temperature increases as you going down the or the decomposition of carbonate. Group 2 nitrates also, they undergo thermal decomposition. Here you have to remember the products, byproducts also. If you decompose it, you will have calcium oxide plus NO2 plus O, in which you have to remember that this NO2, it is a brown colored gas. Okay, write it down.
Yes, ma'am.
So can you tell me what is the answer of this question number 1? Calcium atomic number is 20.
Ma'am, B.
6 plus 6, 12, 12 plus 2, 14, 14 plus 2, 16, 16 plus 2, 18. Correct? And in calcium outermost, it is your alkaline earth metal, bro. And we have discussed about alkaline earth metal that the outermost electron should be S2, right?
Yes, ma'am.
Which is answer C. Now write a half equation to show the conversion of calcium atom into a calcium ion. Okay, so you have a calcium atom. You have to change it into calcium 2 plus. So you have to add the electron or remove the electron.
Remove an electron, ma'am.
How many? 2 electrons you have to remove. How does the oxidation number, what is the oxidation number of calcium in this?
1, ma'am.
0. It is 0 because oxidation number of your elements, it is 0. Okay, it is 0. So if you have Na, magnesium, so if it is written alone, then the oxidation number is 0. We'll study this in redox reaction. Then notice the oxidation number here, it is plus 2. So 0 to plus 2, oxidation or reduction?